Welcome to section 10.6, circles and arcs. This is in the chapter on areas. So we need to define what a circle is since we haven't defined a circle yet in the context of this class. So a circle is the set of all points the same distance from a single point. That single point is called the center of our circle. Right? And that distance, that's the same distance all the way around, is called our radius. So a circle can be defined by its radius alone. The central angle, just like we did with regular polygons, is an angle with a vertex at the center of a circle. So in this case, we need two central angles. What about angle DCB and angle ACB? See, notice the vertex at the center. And for this one, also, the vertex at the center. Name a major arc. Right? And a major arc is an arc more than half a circle. Means it measures more than 180 degrees. So a major arc, we're going to label like this. Major arcs use 3 letters to define them, while minor arcs only use 2. So in here, an arc goes around the edge of the circle. So if I started at B here and went all the way to there, that major arc, B, D, A. B gives me the starting point. The second letter that gives me the direction, and A, the last letter, gives me the ending point. We show an arc by having a little hat over it, just like that. That'll be a major. And then a minor arc is an arc less than half the circle. And for minor arcs, we only use 2 letters. So minor arc in red here. What about just arc AB? So AB with a hat over it. Or what about this arc right here in purple? Arc TB. So those are 2 minor arcs, less than half a circle. And then a semicircle is simply an arc that's exactly half the circle. So measures exactly 180 degrees. So arc ABD will be a semicircle, exactly half the circle. Any questions so far? The vocabulary of circles. Moving forward, we can find the measures of arcs. All the way around the circle measures 360 degrees. And we know all of our central angles summed together equals 360 degrees. So the measure of a minor arc is equal to the measure of its corresponding central angle. So if we know the central angle, that's also the measure of the arc. The measure of a major arc is the measure of the related minor arc subtracted by 360. So if I know the minor arc, to find the major arc, I can take 360 and subtract that minor arc. And a semicircle always measures 180 degrees. So see if you can do example 1 down here on your own. I'll give you a couple minutes, and then I'll give you those answers. All right, so PR, looking at that, all the way, that's exactly half of the circle, so that's going to measure 180 degrees. RS, so here to here, this purple one, if the central angle there is 60, the arc measures the same, 60 degrees. Next one, I'll do in green. P gives me the starting point, the direction through R all the way to Q. Right? Since all the way around the circle is 360, this is going to be 360 minus 40, or 320 degrees for the arc. And PQR, going this direction, I'll use blue PQR. That's also a semicircle, so that's 180 degrees. All right, moving forward. The circumference of a circle is 2 pi r, or pi times diameter, where d is the diameter and r is the radius. The number pi is irrational. What does that mean? So irrational numbers never terminate or repeat. They can keep going on and on forever. Right? These numbers are best expressed in such as pi, or in terms of radicals. We see a lot of radicals turn out to be irrational numbers. All right? Also, what is pi exactly? Pi is essentially for any circle in the entire universe, the ratio of the circumference to the diameter. Right? So what pi is, it's just the number of times the diameter can wrap around the outside of a circle. How many times does the diameter go around a circle? 3 and a little more. So 3.14 continues. Right? So many properties of circles deal with ratios that stay the same no matter what size the circle is. How could you use the idea of similarity transformations to help prove that all circles are similar? Be sure to draw and label pictures in your explanation. All right, so all circles are similar, right? Remember what the idea for similar polygons is. All internal angles are congruent, and then the corresponding sides have the same scale factor. For circles, we don't have internal angles. There aren't any angles in a circle. So the scale factor is just going to be the ratio of the radius, or the ratio of the diameter of the circles. So using the beauty of a smartboard, I can draw a couple circles. And remember similarity transformations. Right? We wanted to go ahead and be able to move one figure on top of the other, and then dilate it to the correct size. So let's see if I can do that with this little circle here. Take this, drag it. So I'm doing a translation. And then go ahead and increase the size until it's perfectly on top. So my similarity transformation, I translate it and then dilate. Any circle can be dilated to equal any other circle. So all circles are similar to each other. All right, so what's our goal here? Today's lesson, we would like to be able to figure out the length of an arc. All right, so what we're going to do is, golf circles are 360 degrees. If I can find the arc measure, I can create a fraction of the circle that that arc represents. Okay, it's all the way around is 360. If I know the arc measure, I know the fraction of the circle that it represents. I can then multiply that by the circumference to find the length of just that section of circle. So let's see how this works. So I want to figure out the length of AB here. So I want to find the circumference. I have the radius. So circumference is going to be 2 pi r. The circumference of this circle is 2 pi times 5. Our circumference is 10 pi. Now I want to figure out what fraction of the circle this represents. So I'm going to take 36 over 360. And we can just divide that to get a fraction, but why not just go ahead and reduce it, right? So we can divide it to get a decimal, or just reduce it to the lowest possible fraction. Or if you don't even want to do that, if I want to find the length, I can just take this and multiply it by the circumference. So the measure, the length of AB is 360 pi over 360. Those will cancel out. So the length of AB is just pi. You guys try example B using that same procedure to find the length of EF. All right, so I want to find the length of EF here. So what fraction of the circle does it represent? 100 over 360. And what is the circumference of the circle? 2 pi times 7. Essentially, I can just multiply all of those together on top and then divide by 360. That'll give me some length. Make sure you use the pi button on your calculator. And I get 12.2, and this is in meters, right? And this is pi meters on that one as well. Right? So that's the portion of the circle that that represents. Question so far? All right. We have our track. The track has lanes that are 1.25 meters wide. Each end is 180 degrees, arc with a radius of 29 meters to the first lane. If the straightaways are 108.9 meters, what's the distance around lane 1? What's the distance around lane 2? What do we call, is anyone in track in here? What's one lap around the track? 400 meters. And when you're doing a 400-meter race, does everyone start at the same position on the track? No, right? They stagger them. Why? Because the distance around the inner lanes are shorter than the distance as you move out. So that's the reason for the stagger when you're doing those longer races. All right, so let's see what the actual length of that stagger is. So around lane 1, we have one way to figure this out. We have this semicircle here, and then I have this semicircle here. I want to go ahead and figure out the circumference of that circle. All right, so I'm given this radius. So that first lane is 29 meters. So to figure out these curve distances, I'm going to take 2 pi times 29. So that circumference, so that whole circle is 182.2, right? Where half of that's there and half of that's there. So for the distance around lane 1, we have the straightaways, which are 108.9. There's 2 of them. Right? So we have this straightaway here and this straightaway there. What was 108.9? So 2 times 108.9. And then add the curved parts. 182.2. Let's see what we get. And we get exactly 400 meters. Ooh. What about lane 2? So lane 2, we're going to take the radius, right? And that was 29. We're going to add another 1¼ meters to that. So what we're going to do is change that radius to 30.25. And then go ahead and add that to the 2 straightaways. So now, let's go ahead and plug these in. And I get 2 times 30.25 times 190.1. And then the distance around lane 2 would be, for part B, 2 times 108.9 plus 190.1. And I get 407.9 meters. So the stagger is about 8 meters to go out to that next lane. All right. So using this idea in track and field. Right, the last example for today. A tire has a rim diameter of 17 inches. So we have our rim right here. I'm going to redraw this, make it a little bit easier for me to visualize and deal with. So there's my tire. I have a rim diameter. That's all the way across. We're talking about a diameter now of 17 inches. And then the sidewall is 4.3. How many revolutions will the tire make traveling 100 feet? We want to know how many times the tire will go around if it travels 100 feet. So this is much how the odometer on your car works, how it keeps track of how many miles your car travels by just simply counting revolutions. So first, I want to figure out the circumference of this. I'm going to use 2 pi r, or I can use pi times diameter, right? Either way will be fine. So pi times diameter might work a little bit easier. Well, they're both the same, right? But since I know the sidewall is 4.33, so that's going to be 4.33 over there. So the diameter is just 17 plus 4.33 plus 4.33 again. And I get a diameter of 25.66. And therefore my circumference, 25.66 pi. Or 80.6 inches. Right, so that's all the way around the edge. I want to see how many revolutions will the tire take traveling 100 feet. But I'm in inches. Can I turn this inches into feet? What do I have to do? Divide by 12. Very good. I'm going to divide by 12, and this will give me the number of feet the circumference of the tire is. So I get 6.7 feet. And then how many revolutions in 100 feet? I'm just going to take 100 and divide it by 6.7. And I get 14.9. Or about 15 revolutions. I hope you enjoyed this video. Come back soon now.